Streams change the surface of the earth more than any other surface process. They do this by the processes of erosion, transporting that eroded material, and finally depositing it. The sediment deposited by a river is called alluvium. One stream can do all these processes, but it does at different parts. At the steep headwaters of a stream, you have a very high erosion rate. Along its trunk, you have both erosion and deposition, and at the very gentle mouth, you have only deposition. We can call the steep headwaters young, the middle mature, and the mouth we can refer to as being old. However, one river, given enough time, can go through all these processes. So a mountain river can wear away the mountain till it exists no longer, and the entire landscape is flat. This peneplain is the result of so much river erosion that there's almost no gradient left at all. All of the rivers that would drain this peneplain would be old. Peneplains are very rare, however, because plate tectonics has a nice way of lifting the land back up into the air. The earth doesn't look as boring as this area in northern Canada. The river valley will change through time because of this erosion and deposition. You can see the youngest of the river valleys. It has a very high gradient. It hasn't eroded the mountain away, so it has a high elevation, giving it a high gradient or slope. Whereas the mature river has eroded away the mountain and now has a very low gradient. The other obvious difference is the width and the shape of the valley. The young valley is narrow and deep. It has a V shape, whereas a mature river has a very, very broad shape, almost a U. Looking at a young river, notice that we have waterfalls and rapids. If you see any white water, you know you've got a young river. Over a period of time, the waterfall, located right here, has moved back. That movement is called headward erosion because it's eroding toward the headwaters. Eventually, every waterfall will erode itself out of existence. The other obvious change happening to this river is that it is down-cutting. This river has only bedrock. There's no sediment deposited by this young river. These are all young rivers. You see the white water and you see a nice V-shaped valley. Eventually, of course, the river slows down and starts depositing some sediment. First, it might be just a sandbar on the inside of a slight curve, but eventually that sediment becomes a wide floodplain. Plain because it's flat, flood because it's covered in water during floods. If you have a floodplain, then the stream starts to loop along it. These loops are called meanders. And when a meander hits the side of the bedrock, it erodes it by lateral erosion. But we're also starting to form some tributaries. So floodplain with meander, development of tributaries, and lateral erosions are the hallmarks of a mature river. We're standing on the bedrock looking down at the floodplain. And here you can see it has eroded into the bedrock, making the stream valley wider. Here we have a good example of some more meanders. When a meander cuts itself off, you have what's known as an oxbow lake. By the time a river gets very old, the floodplain is so wide that a meander almost never gets to erode away any of the bedrock again. Also notice we have a few more features here. On the side of the river, every time it floods, it deposits a little more sediment on either side of the stream channel. That becomes a natural levee. The tributaries have a hard time getting through to the stream, so very often they will parallel the stream for a while before they join it. Those tributaries are called yazoo streams or yazoo tributaries. Some of these oxbow lakes are drying up and it becomes very, very swampy. So here we have one of the best examples of an old river, and that is the lower Mississippi. The floodplain is gigantic. And here we have a river called the Yazoo River. which has given its name to those tributaries that flow along the floodplain. This is a natural levee. It doesn't look all that impressive, but all it has to do is be a little bit higher than the floodplain around it, and it prevents the water in the floodplain from draining very well. We often take the sides of the river with their natural levees, and we make a much larger levee, an artificial levee, to prevent the rivers from flooding. You can see the swampiness along the floodplain of the Mississippi River. This back swamp probably received a recent flood because you can see the high water mark on the trees. By the way, if you have trees, you call it a swamp, and if you have only grasses, you call it a marsh. Along the Mississippi, they tend to refer to the swampy areas as the bayou. Here's a summary of all the features I just talked about. Whether a river is young, mature, or old, it's a gradual process that could happen in different parts of one stream, or it could happen to one stream over time, making a young river become mature, and finally, an old river.
Bill Nye the Science Guy.
Hey, I'm in here. I'm in this giant freezer. Now, let's see what happens when I come outside where you are. See, the surface of my bubble helmet of science turns cloudy. That's because water vapor, which was floating around in the air, sticks to the cold surface in little liquid water droplets. Now, this process, this effect, this thing that happens is called condensation. It's the same thing that happens to people who wear glasses when they come in after being outside on a cold day. It's where clouds come from. Where'd you guys go? Oh, funny. Oh, very funny. Anyway, condensation is sort of the opposite of evaporation. Instead of liquid water gaining energy and becoming a vapor, water vapor loses energy and becomes a liquid. Little tiny droplets that stick to cold surfaces. That's a very important thing about condensation. Water vapor needs a place to stick in order for condensation to happen.
Look at the glass next time you drink your milk. Does it seem to sweat? Well, the glass isn't really sweating, of course, but it is wet. It's just the water vapor in the nearby air being condensed.
When clouds form, water vapor turns into tiny liquid water drops. But in order for that to happen, the water has to have some place to stick. It has to have something to stick to. So take a look at this. This is our big glass jug cloud apparatus of science. And we're going to make a cloud in here. First, we'll add a little water. This will be the water that will form our cloud. Just swirling it around a little. There. Now, using this pump, we'll pressurize the big glass jug. Then when I pull this rubber stopper off, the air in the jug will expand. And that's when a cloud should form. 3, 2, 1! See, nothing happened. That's because the water vapor didn't have anything to stick to. So what we're gonna do is add some dust. Just a tiny amount of dust. And to make the dust, we'll use the smoke from these 2 matches. That's all the dust we need to form a cloud. Now watch. We'll pressurize it again. When I pull it off, the air in the jug expands. And when it expands, it cools off. The same thing happens to air masses when they get blown around by the wind and pushed up high into the sky. 3, 2, 1! See? It's a cloud. It's the water cycle. It's science.
Hi, I'm Emerald Robinson, and in this What Is video, we're going to investigate a very unique formation of ice called a glacier. A glacier is defined as a slowly moving river of ice, but not all masses of ice are glaciers. To qualify to be a glacier, ice must be at least 6/100 of a square mile in size and over 164 feet thick. Earth's largest glacier is Eastern Antarctica's Lambert Glacier, which is about 60 miles wide, over 250 miles long, and over 8,000 feet thick. Glaciers form in places where snow accumulates over a long period of time. As the snow gets deeper, the resulting weight and pressure turns the bottom layers of snow into ice. This high pressure, combined with the force of gravity, causes the glacier to move. Although most glaciers move very slowly, some move as fast as 100 feet per day. Glaciers exist on every continent and play a major role in shaping the face of the Earth through erosion. Water from the bottom layer of the glacier seeps into cracks in the Earth, where it freezes and expands, loosening rocks and boulders from the Earth's surface. These rocks are dragged along the glacier's path. The Earth beneath the glacier becomes smooth as smaller rocks and debris become frozen in the glacier's lower layers, acting like sandpaper. Glaciers carve lakes and valleys, form natural dams, and create riverbeds. The water that melts from a glacier's surface is the largest source of fresh water on the planet. Although glacier melt, also called retreat, is a normal part of the water cycle, scientists have noted that glaciers are retreating faster and further than ever, and point to this as evidence of global warming.
I feel like I'm at the ocean.
Except here, the waves are man-made.
Hi, Jacob and Catherine. I'm Dr. Hoffman from Old Dominion University.
Hi. This is a great place to do research.
We've been wondering, what is a tide exactly?
A tide is the regular rise and fall of the surface of the ocean due to the gravitational force of the sun and the moon on our Earth.
We learned that gravity is a force that exists between all objects.
And it makes objects fall to Earth.
That's right, and the bigger the objects and the closer they are to one another, the stronger the gravitational attraction between them.
The sun is much larger than the Earth and the moon, but a lot farther away from the Earth than the moon. So which one causes the tides?
They both do, but the moon plays the bigger role, being about twice as strong as the sun. As the two of them create a gravitational force on the Earth's oceans, it causes the water to move upwards towards the sun and the moon.
And the Earth's gravity holds the water down.
Right, but the tidal forces pull water sideways along the surface of the Earth, and this tug-of-war creates a bulge in the surface of the ocean.
If the moon's influence is stronger than the sun's, then is the bulge bigger beneath the moon?
Yes, and due to the rotational motion of the Earth-Moon-Sun system, there is also a bulge on the opposite side of the Earth away from the sun and the moon. These bulges of water are large waves that we call high tides.
So if the water bulges on opposite sides, then it must draw water away from the area between the bulges.
Very good, and that is where low tides occur.
How often do we have high and low tides?
Many coastal locations, such as the Atlantic and Pacific coast, experience 2 high and 2 low tides each day. But some areas, such as the Gulf of Mexico, only have 1 of each.
Do the tides in a particular place always occur at the same time?
No, but the answer is a little bit complicated. On average, high tides occur every 12 hours and 24 minutes. The Earth spins on its axis every 24 hours, so if you divide 24 by 2, you get 12. The extra 24 minutes is because of the moon's orbit about the Earth.
Would high tides help bring objects floating in the water onto the shore?
Tides do not typically have much of a role in transporting objects in the ocean. You can think of tides as a big sloshing motion where objects go as far in one direction as in the other. Here, let's check it out.
That was cool. But what about the waves?
Jacob, can you get in the pool?
Can I?
See the waves around Jacob? They look like they're moving the water forward, but actually they aren't.
How is it that I stay in the same place?
Each particle of water in a wave moves around in a circle. Energy moves forward while water particles remain in the same place, so an object floating on the water will rise and fall as the wave passes, but the object will not move forward.
I think we definitely need more research about waves.
Me too. Thanks, Dr. Hoffman.
You're welcome. Enjoy the wave pool.
You better stop researching the waves if you want to get there on time. Bianca does not like to be late.
We hear about strange things from distant places being washed up on our shores all the time, but how do they get there? Ocean currents are the movements of surface water in the oceans. Their direction is influenced by many factors, including the rotation of the Earth, the size and shapes of the continents, the prevailing winds, and even water density. Ocean currents caused by prevailing winds are called drift currents. In the northern hemisphere, the circulation of the oceans is clockwise, and in the southern hemisphere, the currents are anti-clockwise. Currents originating from the polar regions carry cold water. There's the California current, the Peru or Humboldt current, the Labrador, Canaries, Benguela, the Antarctic circumpolar currents, and the Oyashio. Currents originating from the equatorial regions carry warm water. There's the Gulf Stream and North Atlantic Drift, the Brazil current, the North and South equatorial currents, and the Kuroshio. So perhaps it's not so surprising that many of the items that are washed ashore originate from far-off places thousands of miles away.